So now we want to look at the mean and the standard deviation of our distributions. So the mean is also called the expected value here if you're talking about a probability distribution function. So let's first do the mean and the variance, which is just the square of the standard deviation. And let's do it for a discrete probability distribution. That's what we've been considering so far. So the mean, also called the expected value or the long-term relative frequency here of the probability experiment, is just the sum of the x value times its probability. So the reason that this works is think if you had 3 test scores and you wanted to find the average of them. So say you had 60, 70, and 80. And 70 is actually the median. It's also the mean there. But if you wanted to find the average of these, you would just add them up and you would divide by 3. Okay, well, that's actually what's being done here, except the probability is going to be the multiplier. So you could have written this as 1/3 times 60 plus 1/3 times 70, and then plus 1/3 times 80, because it's equally likely that you would take each exam. So now we've got value times probability, value times probability, value times probability. Okay, that's what we're doing here. So it's just that all these are the same fraction, 1/3, 1/3, 1/3. You're equally likely, but these probabilities don't have to be equally likely. And then the variance, to find the variance, you sum up the difference between the individual random variable and the mean, so x minus mu. You square that and multiply it by the probability. So what this is doing is it's finding the deviation squared, and when you sum things up, multiplying by the probability, that's finding the average. So this is the average of the squared deviations. That's exactly what we did when we were examining regular data rather than random variable. And then a shortcut formula is if you sum up x squared times the probability and subtract the mean squared, that'll give you the variance. And then your standard deviation, you just take the square root. So that's similar to what we did with regular data. So let's look at an example. According to the National Weather Service, probability of a tornado in Kankakee County is as follows. That's given in this table. We want to find the mean, the standard deviation, and then the probability that our random variable x would be greater than the mean plus 2 standard deviations. Okay, so let's go ahead and fill in this table. I've done an extension table here for x times probability of x and x squared times probability of x, because the x squared probability of x gets used here, and then the mean x times probability of x gets used right there. So we just multiply straight across. 0 times 0.1 is 0. 1 times 0.4, 0.4. 2 times 0.2, 0.4. 3 times 0.1, 0.3. 4 times 0.1, 0.4. 5 times 0.1, 0.5. And then x squared times probability of x. So we square this x value and then multiply it by the second column. 0 squared times 1, 0. 1 squared is 1 times 0.4, 0.4. 2 squared is 4 times 0.2 is 0.8. 3 squared is 9 times 0.1 is 0.9. 4 squared 16 times 0.1, 1.6. 5 squared 25 times 0.1, 2.5. And then we sum these up. So let's see, we got 3.4s, that's a 1.2 and 0.8. This is 2.0. And that's the total, or the sum, of the x times probability of x column. So our mean, which is the sum of the x times probability column, is just 2. So that's saying the mean or the expected number of tornadoes annually is 2. All right, so now we have to find our x squared probability of x, sum that up, and subtract off the mean. That'll give our variance. So we've got our x squared p of x. If we sum these up, let's see here, 1.6 plus 0.4 is 2, and another 1.7, 3.7, 5.7, that's going to be 6.2. So then our variance, sigma squared, is the sum of the x squared p of x, that's the 6.2, minus the mean squared, which is our 2. So this is 6.2 minus 4, that is going to be 2.2, and then our standard deviation is square root of 2.2. So if we pull out the calculator here, we are going to do a square root 2.2, 1.483, so approximately 1.48. I added one additional decimal place. So there's our mean and standard deviation. So we got these two. Now we need to find the probability that x is greater than the mean plus 2 standard deviations. So probability that the random variable is greater than the mean plus 2 standard deviations. Well, let's put in the numbers here. So that's saying the probability that x is greater than our mean is 2, plus 2 times the standard deviation, so 2 times that 1.48. And so that is asking what's the probability that x is greater than. We want to key this into the calculator. So 2 times 1.48 is 2.96, plus 2 is 4.96. So that's just asking what are the chances x is greater than 4.96. Well, there's only one value in the x column here that's greater than 4.96. It's 5. So this is just asking what is the probability of 5 tornadoes. That's the only value that's more than 2 standard deviations above. And that probability is 0.1. And there we have it. We answered all 3 questions.